Mm.
Hi, everyone.
Hello, good afternoon.
Yes, good afternoon, everyone.
Hello, good afternoon, sir.
Yeah, you are welcome to our class.
Thank you.
Let's have an introduction to this very interesting course unit. My name is Dr. Kasim Kalinachi. I'm a senior lecturer in the School of Technology, and Engineering, and I'm also the dean of the school. It's a pleasure having you in my class. And yeah, before we continue, let me actually first share the course outline, what we are going to cover this semester before we actually start. All these things have been uploaded on the e-learning portal. I'm going to make them active once my class is finished. So I'm sharing the course outline of foundations of data science. Just a few seconds. So I'm hoping you can see my screen.
Yes, we can view your screen.
Yes, this is the course outline. This course introduces you guys to the foundations of data science, including data collection, pre-processing, statistical techniques, and visualization methods, and many other things that we're going to see in the course of this semester. The main objectives: to understand data collection and pre-processing techniques, perform statistical analysis and exploratory data analysis. We shall do all the things, visualize and interpret datasets effectively. By the time you finish the module, these are the things that you'll be able to do to demonstrate proficiency in data preparation techniques, conduct exploratory and statistical data analysis, create and interpret effective visualizations. In a nutshell, this is what we're going to cover. Okay, as much as it says 24 here, but there are actually 45. This was an error, I think, made by the people who made this curriculum. I'll be able to modify this one later, but I can leave it at 24. So we shall spend much time doing much of the hands-on during the course. But of course, the first lecture and maybe the second will be able to give us the theoretical foundations of the entire module. Then we can jump into the actual hands-on that we shall be doing together. These are some of the references, but of course, we shall be able to use some of those that I'm going to share with you along the way. Before we actually continue, I want to make clarifications on the following. This is the application of some of the skills that you're going to be learning from other courses. I don't know whether all of us have the computer science background. How many of us are not from computer science background or IT? By show of hands. So Mheza Frank, you're from which background?
Thank you very much, Dr. Kalinaki. I am political science undergrad, social studies postgrad.
Okay.
And I have been working in research, social science research, basic and applied research.
Okay, that's interesting. Asime, Henry?
Thank you so much. My background is really M&E and statistics. Thank you.
And then Daniel?
Thank you. My background is mainly in the water area. I'm a water technician. And then I would say some computer, but not really computer science. I have a bachelor's in computer education, though we shared some courses with the computer science students at undergraduate level. Thank you.
I see. Lomisa Desire. She's from medicine. Now, now that we have some individuals in my class who do not have the actual grounding of the computing discipline, especially some of the tools we're going to be using in this class are from those who have had a background in them, but of course you can still be able to learn some of those things. We have a new course. There's a course called machine learning. There's also another course called programming for data science, which will be taught by Dr. Stewart. There has been some issues. Daniel, can put down your hand. There has been some issues with the e-learning platform. Some modules were not appearing there for the staff, so they couldn't be able to engage with you. We are working around the clock to ensure that we can harmonize all the things. Usually the start of the semester is like this. There's always some chaos that we have to deal with, but rest assured, everything is under control. The next weekend, everything will be fully operational as expected. So we apologize for that on behalf of my colleagues and even the school. Back to the aspect of the backgrounds that we have. Now that you guys have other courses that you'll be studying, in this course, basically we apply some of the skills we learned from other courses. For instance, programming for AI and data scientists, which will be taken by Dr. Stewart. He will teach you the Python. However, I must emphasize this. You should do a lot of self-learning also on your own. I'm hoping you have the gadgets, you have the machines, the computers already, and access to the internet and other resources which I'll be able to share with you along the way. You'll do more of the self-study, self-learning to try to be faster, because we have basically 14 weeks. If I say that I'm going to teach you programming, then I might lose track on what I'm supposed to cover ideally in my course. Okay, so yes, Dr. Stewart will take you through the programming part of it. Me, I'm using the programming that Dr. Stewart will be teaching you to actually apply it in analyzing data sets. Some of the things probably I think he'll be able to cover some of those, but mine will be entirely on the application end. So that calls for one thing, that you need to actually learn. If you don't have Python background, you don't have skills in how to program in Python, you might need to go and do some self-study. Along with what Dr. Stewart will be taking you through, of course, we'll be teaching you Python as well. So you will need to do some self-study as well. Since this is a weekend program, I know some of us are working, so we might not really have time to engage in self-study, but you can fix 1 hour every day at your workplace and be able to get some few skills. Otherwise, it becomes a little bit challenging. I have to be honest with you. Computer science requires some of these skills to be able to make everything very smooth for you. I'm not saying they are not doable. They are. You just have to have that commitment and put in extra effort to ensure that you can learn. I'll provide some few resources on how to learn Python and stuff, but me, I will be majorly on the side of the application end. Because if I say I'm going to teach Python, then I go to data science, now, trust me, the 14 weeks won't be enough for us. Again, this will be taught by my other colleagues, and you're supposed to do some other extra effort on your own to ensure that you can be up to speed with all the content. I hope that is clear. So I'm going to introduce data science in general. Let me share my slides. And then we shall see how we will go. Don't worry, I'll give you some of the resources that I also used when I was starting out as a data scientist, not so many years ago. My PhD is in computer science, but data science, I was mainly dealing with images. Okay, but of course, we shall first of all deal with the textual data, then we shall see how far we can go. In case time allows, we can also deal with images as well. So I've shared my screen. Let us get to know some basic concepts of data science. Today is our introductory class, and we shall be able to cover a few things here that will get us started with the discipline. The objectives, you'll be able to gain a clear understanding of what data science is and why it matters. The insights into the interdisciplinary nature of the field. Data scientists work with people from other fields. And of course, familiarity with data science life cycle. What do we go through to ensure that we can analyze data sets and provide some kind of insights? This topic establishes the conceptual and technical foundation upon which the rest of the course is built. So I'll be making reference to some of the things we're going to study today. Of course, we shall be able to look at other things along the way as we go throughout the semester. Overview of data science. Even before we proceed, what comes to your mind? I know we have people from other backgrounds, but maybe you might have heard of this word, data science. Can anyone be able to tell us what they understand by data science before I give you what I have for you today? Yes. Anyone? Try and explain to us what they understand by data science before we can be able to share collectively together here. Okay, without wasting time, this Frank, you have an idea of what it is? Please tell us.
I'd imagine it is an attempt to look at data from different perspectives that enables us to prove facts, to verify, to clarify, and the art of doing so.
Okay, you have an idea, but let's see what I have for you. Thank you so much for your trial. It is a multidisciplinary field that focuses on extracting meaningful insights. The keywords I was looking for here is extracting and insights from data sets. And of course, we can only do this using a combination of techniques drawn from statistics. I'm glad we have some people from statistics background here. We shall be doing some kind of statistics also in this course as we analyze our data sets, computer science, mathematics, and even domain expertise. So what does this definition tell you? It tells you one thing, that we are not an island as computer scientists or people who deal with data science. We deal with people from multiple disciplines. For instance, if the banker wanted me to give insights into the loan repayment patterns in his bank, of course, me, I'm a computer scientist. He's a banker. He or she is a banker. He is a domain expert in banking. Me, I'm not a domain expert in banking. I'm in the field of computer science, just like you. So I'm going to have to work with another person who will give me his data sets that I'm supposed to study, clean, pre-process, analyze, and extract insights to provide informed decisions. I don't know if that makes sense to you. It's not something that we have to work with us as a computer scientists. Rather, we work with people from other fields. It involves the entire process of working with data from data collection and preparation to analysis, visualization, and even decision making. We work with people from other fields. We work with people from marketing, people from the social science, people from medicine, for instance, people in healthcare. I don't know whether you remember during COVID, I don't know whether some of us were very active during COVID, but there was a lot of data science going on during COVID. There's visualizations of the infection rates, the spread of the disease, people who are dying, all that was data, but from the medicine. People who are visualizing it, all those are data scientists, not doctors. You understand? If you talk about weather forecasting, these are people from the meteorology department. They're not computer scientists. They give us this kind of data and we can forecast. We can prepare this kind of data and provide forecasts. That's done by computer scientists, but the data comes from people who are not from computer science. You talk about UBOS, Uganda Bureau of Statistics. Last time they were doing population census. Okay. They collect all this kind of data and they give data scientists to do the kind of insights, extraction of insights. You talk of the elections. Remember during the elections, how they were breaking down the different voter counts for districts, counties, parishes and stuff, breaking it down to that small level. That is the role of data scientists. But people who are collecting the data are probably not computer scientists. Once they've done the collection, then they give us, then we analyze. The tools are there. Sometimes they are there. We just simply feed in the data, and everything can be done according to how instructions were made. So yeah, hold on just a minute. My boss is calling me here. Hold on. So yeah, I think you now get the idea of where I'm coming from in respect to data scientists, so data science as a field. So what questions does data science really answer? Now that you've known how multidisciplinary the field is, and the key things we're supposed to do here is extraction of insights from data, visualize it, and provide actionable points for us to make very good decisions, or even our bosses to make very good decisions. However, this field answers the following questions. One, what happened? That is, we call that descriptive analysis or descriptive statistics. What happened? We understand what occurred in the past. I've given you some kind of visualizations here, but of course, I'm going to explain to you what happened. For instance, the guys of Ubos, okay, when they were collecting data, they used to go household, and asking people questions. The things that actually they were asking them are not actually in real time. Some of the things have happened already before. Did you go to school? Yes, I went to school. It's not that you're going to school that very moment. You're going to school. This is something which happened some time back. How many kids do you have? I have 3. You already produced them some time back. Okay. And many other questions I might ask you. Then they collect this kind of data and be able to process it. Okay. So it helps us answer. For instance, if they did the census 5 years ago and they are going to do another census this year or maybe next year, we can answer questions based on a trend of people who went to school. We can make a projection. So data science can tell us that 5 years down the road, what might have happened based on the historical data that we have been able to collect some time back. So data science helps us to understand what occurred in the past already to predict the future. That's the first question that data science answers. 2 is why did it happen? We call that diagnostic analysis, identifying the cause of the outcomes. I'm going to give you an example of the stock exchange. I don't know that some of us understand the stock market, where people go and buy shares and trade, and the companies are listed on the stock exchange. You go and buy shares and keep monitoring the share price. So, assuming you buy your shares today, then tomorrow, the share price is affected by very many factors. One, the annual returns, or I would say the profits that the company was able to announce. If the profits are very good, people are going to go and buy many shares, then the price will go up. If the company made losses, people will say, oh, now let me go and sell my shares because this company is just making losses. I hope you understand what I mean here. 2, it could be a political kind of statement. Maybe the president can say, some of the companies actually, like those companies which were recruiting people going to the Middle East, maybe the president can make a very funny statement about the companies. If one of the company was listed on the stock market, and maybe it is involved it was mentioned by the president in human trafficking, people are going to say, oh, if this company has been cited among the companies doing human trafficking, I'm going to sell my shares. You understand? Then the share price will drop down. That's a political statement just made by a president. I'm just giving an example, made by the president. Sometimes other factors, maybe the owner of the company has died, who was steering everything, and said, how is it going to survive? Now let me sell my shares because now there's so much uncertainty here. So how can data science really help you to answer why it happened? So in this case of the stock exchange, I'll go back to the example of the stock exchange. Because data is being fed into the system, people are buying shares and everything. It can help answer the question why it happened. Because if the share price was maybe 250 shillings today, and tomorrow, because a president, by the way, there are many factors that are fed into this kind of thing. Okay. Someone is calling me. I will not answer them. Hold on. If we feed everything within the system, it can, that trend, that kind of drop in the share price, the data sets and other factors that I've just mentioned can actually help you answer why the share price actually dropped. You understand? So another example could be maybe the company was having what we call tax holidays. It could be a foreign company in the country having tax holidays, and maybe the government stops giving them tax breaks. So what's going to happen? There's going to be some kind of increase in the prices for the things that they're selling. People might say, these guys are now very expensive, or might not buy their products. But if everything is fed into a system, data science can help us tell why it actually happened, because everything is fed into that system. The third question is, what is likely to happen? It's called predictive analytics. Now here it involves now machine learning, which we are going to learn this semester. Mr. Dr. Danish Azamoke will take you through that. And along with my class, other notes, you'll be able to get a few insights about machine learning and see how things actually work. So we can predict based on what we have currently. Okay. Let me give an example. I usually give an example of cars. Or maybe let me go to the factory. Okay, I'll give an example of a factory engine or equipment. There's a field called IoT, or what we call Internet of Things. There we have sensors that are put on some of those equipment, and those sensors are collecting data every now and then. For instance, if it's a pressing machine, maybe then it presses the sheet to create maybe saucepans. Okay, there are sensors that are giving us information such as the throughput, the efficiency, and how it's doing all these things. Now, this information is being fed somewhere. You know, it is telling us how the machine is operating. So, basing on the way the machine is operating and the kind of data we are receiving, we can tell how long this machine is going to be able to run at that pace. Now, whenever we begin receiving in wrong data from the machine, the sensors are recording all this kind of information. We can predict the time it's going to fail. That allows the managers to plan ahead and do the repair works, or calling the guys who are specialists in repairing this kind of equipment, and they'll be able to do what? To repair it before it breaks down. We call that predictive analytics. They predict when machines are going to break down, and they prevent it from happening. That is an example of a factory. Let me go to an example of a shopping platform such as Jumia. Okay. So during the festive seasons, people purchase things a lot, and these guys make a lot of sales and profits from their platform. People are buying during Christmas period or Black Monday, whatever. Basing on the people's purchasing habits, they can predict how much they're going to earn in the next Black Friday or Black November. Just giving an example. They'll predict, because they're going to base on the current information, the current purchasing habits of people, and they can predict what's going to happen. I was doing image processing for my PhD. My PhD was in environmental monitoring, where we could predict the growth of trees. Okay. You could predict that maybe in a given year, maybe in 2 years from now, the trees will have gone up this height. But how do we do that? We based on the current data that we have. You have temporal images. Temporal means images of the same place, but taken at different times. Then you can assess the images. You see the subtle changes on how trees have been growing. You can predict the next 2 years at what height they will be because you're based on what you already have right now. So you can predict what's going to happen in the future. Okay. You can also predict diseases. I used to have my friends who are in the labs. They predict plant diseases. They would take images of these plants. Several images are taken across several years. Then they will know how the disease is spreading. Then they can predict the coverage of this disease on the spread or the spread of this disease on the leaf of maybe maize or maybe soybean or whatever. This is possible because of machine learning. It can do all these things for us. It does what we call forecasting. It's the same thing we use for predicting the weather patterns. Some of you might be and say, how do they know that tomorrow is going to rain? They are basing on historical records of what happened on that particular day with other factors going around. So they feed all this information into that system, which is AI powered, and can make predictions and tell us that tomorrow it's likely to rain and it will be this amount of rain. Okay. Lastly, data science can also answer what should be done. We call that prescriptive analytics. It can guide us in making decisions, which are data-driven. I will take you back to the example of the stock exchange or the stock market. Because the share price is dropping down, all this is based on data. You as a shareholder, what are you going to do? You say, oh, the share price has gone down. People are now selling their shares. So what do? You also sell your shares. Or the share price is going up. It means the companies may be profitable. All this is based on data. Then what do? You also buy shares. So data science is helping you to make an informed decision based on data. If we go by the results from the UBOS when they did their population census, and if we say that those results are very good or very legitimate, though of course we know what happened, some of the results were doctored, okay, just because we are in this country of ours. But if everything was the way it's supposed to be, that kind of data can allow the government to make policies that are going to affect different people. Maybe, for example, people who are disabled. If they know the number of people who are disabled, data science can give us those insights on what to do. What interventions can we do to people who are disabled? Buy them bicycles, know the kind of disability that they have, put their facilities for them, and stuff like that. If they know the actual population of people who are unemployed, who have gone to school, they will try to put up avenues to create more jobs for them. This is data science giving you a way of how to make decisions based on data. So these are very critical questions that data science helps us to answer. We shall be able to do some of these things along the way as we go through this course. Now, this is the interdisciplinary foundations of data science. Which fields are involved here? We have mathematics and statisticians, things like summarizing data, measuring uncertainty, making inferences like probability, hypothesis testing. All this is part of the data science. Computer science and programming, we are going to be using Python. Data scientists use programming languages. The most common languages we use are Python and R. Dr. Stuart Semuju will take you through the programming using Python, because that is what we use. That is the most common language, programming language that we use in our course, and it's the most prominent because it has enough support that you can get from out there. So it enables for you to manipulate data, to automate systems, building AI-powered systems, algorithm development, and even handling large data sets using programming languages such as Python and R. So you learn Python with Dr. Stewart. Then, of course, the other one is domain knowledge, people who are experts in their knowledge, in their areas. If you're going to analyze data from agriculture, you need agricultural guys because those are the guys who know their kind of data sets. For you, your role is to do what? Process it, analyze it, visualize it, and present it to them. So you work with domain experts. The example I've given you, stock markets, you work with stock people in the financial industry, healthcare, you work with doctors, you know. In education, you work with teachers who know the pedagogy. You want to measure, you want to predict learners' outcomes or predict their performance and stuff. You need the educationists who are going to tell you what they're going to measure in terms of parameters. You are not an educationist. You are a computer scientist, or in this case, a data scientist. So you need these kind of people to give you the kind of insights that they are looking for that can help you to process and extract those insights from their data sets. Then, of course, data visualization and communication, which draws from design and cognitive science to present insights clearly and effectively to diverse audiences. How I present my data sets or my data or my, what I've been able to extract from my data, I need people who can actually communicate some of the things properly. Yes, there are those standard visualization methods like bar graphs, pie charts, and stuff. Those ones are very common. But some people have specific ways they want to view their kind of data sets. You have to go to those specifics and be able to understand the requirements of the audience and be able to present it the way they will consume it. This is the life cycle of data science. The first thing is problem definition. Even before we continue, one thing you should know is that this is a repetitive process. The cycle is repetitive. You want to analyze data sets from the UBOS, for instance, there should be a problem. What do you want to achieve? What's the problem? You want to now to find out. Hold on, someone is calling me here. I don't know who is this. Hold on. No, I'll call them back later. So this is the life cycle. We begin with problem definition. We define the objectives and questions. You've been given a data set from UBOS. They should tell you what they want. So once they've told you, then you collect the data. But lucky for us, as data scientists, we work with data that is usually available. Unless, of course, you are going to go through the entire life cycle, we are going to collect your own data and be able to clean it and stuff. But quite often we are called in when there is already data sets available. Our job is to extract insights from it, but sometimes you have to collect it by yourselves. Okay. Then once you've done the collection, you clean it. We are going to do extensive cleaning and pre-processing in our class. You do what you call exploratory data analysis. You identify the trends and patterns in this kind of data sets. You analyze and model. You apply some statistical and analytical techniques to this kind of data set. You visualize it. You bring out some kind of visualization such as bar graphs, scatter diagrams, box plots, pie charts, name them. Communication and decision support, you share the findings with stakeholders, then you iterate and refine. So why is this important at the end here? The data set that they've given you to analyze or to extract insights from can only be cleaned for that particular purpose. Once you're done, it can also be cleaned again for another purpose. So depending on the purpose for which you want to, the insights you want to gain from this kind of data set, you can clean it accordingly. We shall see this in real life when we are working on some kind of data sets that I'm going to provide you with later. But the process is iterative, it's repetitive. And one thing you're going to learn later, that as more data keeps coming in, you have to repeat this process. Okay. Sometimes data is coming in and you've done some kind of pre-processing already, then some new kind of data comes in, then you're supposed to refine it, you're supposed to go back to the first step and be able to continue again like that. So it's continuous, okay? This is a simple visualization of this process that I've just described here. In practice, these workflows are iterative, they're not linear. They require continuous refinement and involve multiple stakeholders to ensure that you can have everything the way you want it to be. You should understand that real-world data projects often involve revisiting earlier steps multiple times. We shall see this in reality when we begin our data science journey together. Which tools do we use in data science? We use programming languages such as Python and R. This is the most common language that we use in our programming. So in our data science, which we are going to use as well in our class. R is also another language that people are using. Maybe someone was talking about him doing action research and stuff, applied research. Maybe they've been using some of these languages, especially like R. Okay. So these are the most common ones that we use. The environments we use, we use Jupyter Notebooks or Jupyter Lab. I will be using Jupyter Lab because it makes my life very much easier when I'm teaching. But of course, there are others as well. There's R Studio as well. There's even Anaconda, okay, which is also another Python environment where you can code up Python and stuff. The tools we use for manipulation of data, we have Pandas, which is in Python, the NumPys, and many other things, scikit, matplotlib, and many other things. We shall discuss these things later as we go along. Then the statistical tools, we have the SciPy for Python, base R, and Teddyverse. The visualization tools that we have matplotlib and Seaborn for visualizing. We talked about in our cycle. There's visualization. How do we visualize the outcomes of our analysis? We use some of these tools, matplotlib and Seaborn. We use ggplot in R, there's plotly, and many others. How do we store our data sets? We store them in CSV. CSV means comma separated values, or sometime in Excel, and even sometime in JSON. JSON is JavaScript notation. We'll discuss it later as we go along. Also, we have RDBMS, or what we call Relational Database Management Systems. Now, this is for people who are more into the storage systems, so they prefer using RDBMS. Then how do we collaborate as data scientists? We use what we call the Git and GitHub. Git is for version control. It controls the versions of whatever stuff we've been able to come up with. Then GitHub is for collaboration and code repository. We can store our codes there and we can share them. In my class, we shall be using GitHub, where I can be able to see your codes there. Instead of you trying to play around with the codes, zipping them and stuff, we have these platforms already in place, so we can be able to take advantage of them. There's Markdown also for reproducible reports. We shall also see some of those as we go along. Real-world applications and case studies of data science is healthcare, like disease trend analysis. We saw it during the COVID time, how they were telling us the different variants of diseases of the COVID. Okay. Patient outcome monitoring as well. Resource allocation, all this is in the healthcare domain. In cybersecurity. Okay. I also did cybersecurity as well. In fact, before my PhD, before diving into the machine learning and AI stuff, my main research proposal was actually to do with cybersecurity using machine learning. So we would basically analyze the logs. What are logs? These are data sets that are stored when systems are operating, such as networks, servers, and stuff. Each time you transfer a file, there's some kind of data set that are stored there. Each time someone accesses your systems, some kind of data is stored in what we call log files. We call that metadata. So we can be able to analyze these kind of data sets and we know any anomalous activities going on. That is very important in cybersecurity. For instance, you've been breached, someone has hacked into your systems. How do you know? You got logs. And the best way to get logs is using what we call data science methods like machine learning and stuff. You analyze them and see the anomaly elements in this kind of data sets. And other things, education, learning analytics, you want to predict students' performance. All this is the application areas of data science, even in curriculum development. Nowadays, we're talking about CBC. How are they able to come to CBC? They've been analyzing the trend of the performance of individuals when they go to the field of work. They don't have the skill sets to be able to thrive in the field of work. So now CBC is now on board. Competence-based curriculum or competence-based education and training, CBET. Now it's now being called CBET. Government and public policy, like census and population analysis, I've been telling you about the UBOS thing, urban planning, service delivery optimization. All this is the application of data science. We have finance and business in the banking industry, fraud detection and stuff. All that is possible because of data science. Transportation and logistics, route optimization. All of us, I think, have ever used Safe Border. How do you think it's able to give you the best route? It's because there is some kind of data which is called a mapping data. It analyzes the real-time traffic along the roads and gives you the optimal route that you can use to reach your destination. It wouldn't be possible without data. Okay. Fleet management. You see most of these trucks moving around from Mombasa to Uganda, from wherever. They are managed somewhere. They are tracking them wherever they are going. But how are they able to achieve that? Because they have systems that are AI powered, that have data, mapping data or location-based kind of data, and they will know the trucks and how they are moving, whether they've stopped and stuff. Traffic pattern analysis. I don't know, maybe some of you don't use this. Me, I use this. I use this quite often when I'm coming to Kungu, or when I'm leaving the main campus in Matuga, coming back to Entebbe Road. I use Google Maps because it gives me the real-time traffic, and I can know the status of the traffic on the road, even the traffic of the service providers such as MTN and stuff. All that is also possible through data science. Okay. This is an example of disease surveillance. A public health agency collects hospital admission data over several years using data science techniques. Okay. Then what happens in the process? We clean this kind of data. We analyze the disease trends. We visualize, and then we support decision making. This is a simple data science pipeline in the healthcare industry. The overall impact here is better disease surveillance, health system preparedness, improved patient outcomes and stuff. How will they know that people in Kasese are having Marburg? They're based on admissions. They'll say, eh, many guys in these Kasese areas are coming up with Marburg. They're coming to hospital admitting with Marburg. Because systems are recording these things, they can now know based on data. So without data, we have nothing. And nowadays, everything is data-driven. Without data sets or data, we can't make any decisions actually nowadays. Okay. I'll even give you an example of the programs that we are running at the university. If the programs don't have numbers, they don't run. How do we know that? We're based on data. How is this data coming in? People who are applying. I think you get my point. Without data, we cannot proceed. In the present world that we're now living in, we cannot do anything. So our class activity here that we're going to go with today is we're going to compare the different tools for analysis. This will allow you to conduct independent research on data science tools that are out there. Of course, I've given some of them in this class, which I'm going to share once the class has finished. You'll do a comparison of tools based on the features, strengths, and limitations, because in this course, we are going to use some of these tools. Okay, so you're going to have to understand how these tools map different stages of the data science life cycle, and will allow you to develop critical thinking and communication skills as we move forward. So this is a very simple class activity. I will expect a submission probably before next class. I'll put the submission link on the e-learning portal, and yeah, I'll wait for those submissions. Today's class has been basically an introductory class. Get to know what data science is, the different application domains of data science, the life cycle of data science workflows, and many other aspects that we've been able to discuss today. So it's just basically the ice breaking. There are many more things we're going to do, but I assure you, most of the things are going to be hands-on. And in our next class, I'll give you some of the resources that we can be able to go to and learn on our own, because our third class will start straight away getting our hands dirty. So that brings us to the end of our first class today. In case you have any questions, please feel free. to ask any questions. I've shared this already on the e-learning portal. You can always access it there. But like I said, we are going to do more of the hands-on things. So you should be able to have a very good machine. We as data scientists, we always use strong machines, but of course, I'm going to be using some small data sets that don't require so much processing power, so that we could get to know the basics or the foundational knowledge. Then you can scale it up later in case you have proper machine that can be able to run some of those codes. So yeah, that brings us to the end of our class. Any questions? Please feel free to ask any questions. In case there are any questions, feel free to ask. Otherwise, me, I'm done. Yes, Frank.
Your last comment actually was one of the questions I wanted to ask, because it looks like we will need certain specs of we will not need to work with just basic computers. We will need certain type of hardware as well as certain types of software. So maybe you can recommend, because we need to mobilize resources in order to be able to access some of these computer hardwares.
Yes, you're right. But the challenge here is these machines that do the real data science are very expensive. I'll give an example of the machine I'm using. It's 8M, because there are other things that we have to look at when purchasing some of these machines. We have what called the GPU. That is the graphics processing unit. Every machine has a GPU, but these GPUs are different that I'm talking about here. And they'll be very important when it comes to machine learning, where we'll be training some models to predict some things. So depending on the kind of data sets we'll be using, which we shall look at next in our next class, the kind of data sets we are going to be dealing with. Some data sets are very heavy, such as images, videos, audios. We might not deal with videos and audios in this class, but I'm just giving an example. Those ones require enough GPUs to actually render them as you're trying to train the models. However, the experiments we shall be going through will require mostly textual data, which is not so much resource intensive, but in case you want to make this as a career, then you might have to think of buying what you call gaming PCs or gaming machines. Could be also a laptop, but you should make sure there's what you call a GPU. My laptop has 2 GPUs, okay, by NVIDIA. NVIDIA is the company that offers the GPU. Others have GPUs from AMD, American Micro Devices, others from Apple, depending on which one you're using. But in a nutshell, core data science requires these machines because of the requirements in terms of processing. They require extra processing capabilities that are not found in normal laptops. I hope that answers your question. However, I'm sure the laptops that you guys are using will be able to suffice in the course of our class, because I understand being with remote learners, there are challenges usually. So I have to be flexible a little bit. I don't want to say, go and purchase this machine, blah, blah, blah. No, let us go with the baseline, with the threshold that you have a laptop. It will work for us. But of course, if you want to scale it up and make it a real kind of stuff, and you'll be able to be in those data science intensive activities, then of course you might need a very good machine.
We'll
that
be
is
in
clear.
touch.
Yeah, sure, we'll be in touch.
Just in case we have the opportunity, the resources to upscale. Number 2, in our social sciences, we differentiate between data and the information.
That's our next class, actually.
Okay.
Yeah. Today was just an icebreaker, but maybe you can ask in our next class. Okay.
Okay. I'll pass. Then
okay, sure.
The last is a comment. I am also intrigued by the process you go through in this data science, because it is almost related to the machine learning.
Yeah.
I was pleasantly surprised by the potential that one can upgrade their skills and capabilities using machine learning, especially for us who are coming from the social sciences. And listening to you speak, is you're speaking our language of the social sciences, but now you've really put it at the next pedestal, and which means that you are really lifting the art of dealing with data, analyzing it, interpreting it, and making it available for purposes of consumption of policy and programming. You're taking it to a next level, which I'm really dying to, and I'm happy I am in this course. I'm looking forward. I know the concept.
Okay, thank you so much.
Concepts are very complicated. It's like teaching physics in primary school, but because we are coming from social sciences, I know we will cope. We will try and cope because I don't know. One of the other small bits, which is really not very important, what is it with snakes and these computers? You know, this is Anaconda, this is Python. I hear somewhere I will get Cobra, and what is it about?
Now, that's the funny thing with programming languages. They took on what we call reptiles. You know, if you go to some of those, the actual websites of some of those programming languages, they're using reptiles. They're using lizards. They're using snakes. They're basically using those reptiles. I don't know the inspiration where they get it from, but yeah, we should now focus on what we're able to achieve out of them than the actual inspiration as to why they use snakes and stuff. Musema, you have a question?
Yes, hello. Good evening, everybody, and good evening, doctor.
Yes, okay, thank you.
I'm Musema Manas. I'm from the background of IT. I've been also using some of the aspects of data analytics, especially when we are analyzing our networks and what. But now I decided to dive deep into the data science. That's why I got the person to be here. My question is in regard to tools that we use in data science, especially the programming languages like Python and R. So I think maybe I missed something as we were explaining. I would like to know what Python can do that R cannot do. I would like to know the slight difference that it has. Thank you.
That one could be your assignment, but for starters, Python is very robust. It deals with extremely large data sets. Okay. Python requires the actual knowledge of the programming. Even programming R also requires it, but not so much extensive because we have the tool where we use R. That's why most social scientists actually use R because it's very much easier for them. Even other guys who are in sciences but not in computer science are using R to do their work. So the difference here is with the possibilities that you can be able to achieve with one tool. With Python, the possibilities are unlimited. For one reason, there are very many hundreds of thousands of libraries. Libraries are packaged programs that allow you to manipulate data in different formats. For example, NumPy is a library. You can deal with numbers. You talk about pandas. It also allows you to deal with numbers in a particular way. You talk about scikit-learn. It allows you to train a model. You talk about matplotlib as a library. It allows you to visualize. There are many possibilities with Python compared to R. So that's why Python is the most popular language for data scientists. Number two, Python is actually open source. That means you can also create your own library for whatever thing that you're doing and publish it there in the PyPy. It's called pypy.org, that website that has those libraries. And can be accessible by everyone. R is closed, okay? But of course, I'm more focused here on the possibilities that you can be able to achieve with one language compared to the other. The rest of the other differences you can go and explore on your own, but Python is the go-to language for data scientists globally. Segawa?
Yes, thank you, Doctor. I also would like to thank you for the lecture. Mine is just maybe to throw more light on what you are saying about Python and R. I've personally interacted with both, and where you write a line of code in R, you'll need like 3 lines for the same in Python, you need 3 lines for the same in R. When you're offsetting data, you'll need 3 lines or 2 in R, and in Python, you'll write like two words to do the same. Also, maybe I don't know, maybe I'm getting it all wrong, but maybe to in a nutshell, what I would like to tell my colleague that is from the social science class is that since this is a course of artificial intelligence and data science, now what UTAMU did is they broke it into bits and pieces, where if you put them all together, you can collect your data from the field, clean the data, analyze the data, or explore the data, develop a model for it, deploy the model, and use the model. So just these have been broken into bits and portions. So don't make it so hard to fit. It is simply just that way. Thank you.
Okay, thank you so much, Segawa. Your question about Python now. Me, I'm a programmer. I've been doing Python for now 10 years. I've been programming for close to 15 years, I would say. I began programming seriously, I think, 2008, 9 there. But extensively, I began programming in 2012. And for Python, I've been programming from 2013 around there. One thing I can tell you is, maybe programmers who are in this class can bear witness. There's what we call code optimization. Usually when you're starting out to program, you want to write so many lines of code. But over time, as you mature in this language, and you know the tweaks of how you can be able to optimize, because it all comes down to one critical thing, which is the resources that are going to allow us to process these lines of code. Those resources are basically two. One is memory, and the other is the processor. Okay. If you have very many lines of code, it means that the processor is going to have to go through all of them, and that takes time. And of course, the lines of code also translate into what we call space. Okay. So the more the lines of code, the heavier the program is. The fewer the lines of code are, the more efficient the program is, or the more lighter it also becomes. So usually what we do, we try as much as possible to make our programs lighter. So now Python is a simplified programming language. The way we program in Python is different from how we program in C++ and C#. The lines of code in C# or C++ are very many. In Python, there are very few, which makes it very much efficient, very light, and very easy to learn Python than C++ and C, because me, I began learning programming from C. One of the hardest languages to learn is programming in C. So yes, Python is very much lighter. That's why you see it has been adopted by very many programmers globally, and it's now powering some of the most used systems right now, like ChatGPT and others. Okay, because it's a robust language, it has very good user support out there, and you know, yeah, it's the language that you have to go to in case you want to be a proficient and very good data science out there. So then, of course, as you've said here, someone is saying that is plain English. Yeah, of course, most languages are in English. We call them high-level languages. They're all in English. You have to learn this English thing because that's how they've been programmed. They've been made to work, ideally. So yeah, that's it. Any other questions? So that has been our class today. Please let us meet up in our next class next weekend, and we'll see how it will go, inshallah, for all of us. So thank you, guys. See you next week. The notes are there on the e-learning portal. You can always access them. I've made them accessible right now. You can go and access them and be able to go through what we've been able to cover today. Thank you.
Thank you.